So, if you work on a factory floor, a big industrial site, or even a large kitchen, your trash isn't just trash.
Right. It's a classified risk.
Yeah, exactly. We all kind of get our home recycling figured out, but managing waste in a professional setting, that's a whole different ballgame.
It really is.
It's all about this detailed, color-coded protocol that is, frankly, less about being green and more about staying safe and, well, compliant.
That's absolutely right. We're moving way beyond that casual idea of recycling. This is standardized industrial risk management. And today, we're doing a deep dive into the source material for all of this.
Which is?
The Universal Color-Coded Waste Management and Safety Standards.
Sounds a bit dry.
It can be, but this framework is designed to take what could be chaos and turn it into a predictable, safe operation.
Okay, so our mission here is to sort of synthesize all that complex technical language into a practical guide.
Exactly.
We're going to demystify the 5 core bin color codes. And for you listening, understanding these colors isn't just a suggestion.
No, not at all.
It's the key to navigating liability and making sure a site is safe. We want to show you exactly why knowing the difference between, say, a red bin and a yellow bin can be a multi-million-dollar distinction.
Let's start with the lower liability materials.
Okay.
The waste streams that are really focused on resource recovery. And those are segregated into green and blue.
All right, let's start with green. That's for biodegradable and organic waste. What really falls into that bucket on a big industrial scale?
Okay, so think about any day-to-day operation where organic stuff is generated.
Like a canteen.
Exactly. All the food waste, canteen leftovers, garden waste if the site has ground solis, grass clippings.
And what about from the factory floor itself?
Right. Any wooden materials, sawdust from manufacturing or packaging, basically anything that's meant to decompose naturally.
Okay, but this is where we hit our first bit of nuance, isn't it?
It is.
Because the source material says that paper and cardboard can sometimes go into the green bin, but they have to be, and this is key, non-contaminated. So why would a clean organic material like paper get rerouted to recycling instead of just composting?
Yeah, that really gets to the heart of it. It's a question of resource recovery versus composting efficiency.
Ah.
While paper is organic and it'll biodegrade, clean paper and cardboard are just far more valuable for industrial reprocessing.
For turning them back into paper products.
Exactly. Than they are for just making compost.
Right.
So if they're clean, they jump over to the blue bin because the highest economic value is in that recovery.
So that brings us to the blue bins. All recyclable waste that needs physical reprocessing, like melting or crushing.
Correct. This is where you're putting your plastic bottles, your containers, all your metal scraps, aluminum cans, glass.
Right.
If the material is clean, if it's durable, and if it's commercially viable to reprocess, it lands in the blue bin.
So this initial separation, green and blue, it's really the first big logistical choice.
It is. The question is this material going to a composter or is it going to a materials recycling facility?
That makes total sense for resource management. But now we have to pivot because separating organic waste from bottles is, it's tidy, but separating hazardous materials, that's critical.
This is where the stakes get much, much higher.
Here's where it gets really interesting.
Indeed. We're moving now from things you can recover into managing genuine liabilities. And that starts with the red bin.
Designated for hazardous and dangerous waste.
This is, without a doubt, the single most important color on any site when it comes to immediate safety.
Fire prevention, regulatory risk, all of that.
All of it.
So what are the specific materials that push a bin into that red category?
We're talking about materials that pose a severe and immediate threat if they're not handled with specialist protocols.
So not just dirty, but actually dangerous.
Exactly. Highly volatile liquids, corrosive agents, materials with high flash points. Yeah. The standards list chemical containers, solvents, paint cans.
And what about electronics?
Batteries and e-waste, yes, they fall right in here because of the heavy metals and all the embedded toxins.
And critically, in a construction environment, the red bin is also the required container for some really high-risk contaminants.
Like asbestos.
Like asbestos materials. The fact that asbestos gets grouped in with pure chemical solvents, that tells you everything you need to know about how severe the red category is.
It really does. Red waste requires highly specialized licensed disposal. Often high temperature, controlled incineration, or specific chemical detoxification.
Okay, now we get to the really nuanced challenge, the yellow bin.
Right.
Yellow is for non-recyclable or general waste. What's the real operational difference that separates yellow, which is still bad waste from the critically dangerous red bin.
The distinction really centers on the nature and the concentration of the hazard.
Okay.
Yellow is for general waste that you can't safely or efficiently recycle. But it typically doesn't contain substances that are immediately explosive or highly flammable or acutely toxic.
So it's sort of like mixed materials or failed recycling.
That's a great way to put it. Think of it as the stream for failed recycling.
So contaminated packaging, broken equipment parts, mixed stuff you can't separate anymore, or even damaged PPE like soiled gloves.
Correct. All of that goes to yellow. Let's use an example.
Please.
A worker tosses a rag that's soaked in a highly flammable solvent. That rag has to go on the red bin. The fire risk is immediate and it's high.
Right.
But if that same worker tosses, say, a plastic coffee cup with a little coffee stain or a bit of non-hazardous dried glue on it, that goes to yellow.
And the disposal route is totally different.
Totally different. The yellow stream heads to a general landfill or maybe an incineration facility.
Yeah.
The red stream, though, that incurs extraordinary disposal costs because it has to be specially treated.
What's fascinating here is the economic driver behind all this.
Oh, hugely.
If you miscategorize something that belongs in red and put it in the yellow bin, you risk an environmental catastrophe, site contamination, huge fines.
Astronomical fines.
But if you're too cautious and you start throwing general junk into the red bin, you are massively overspending on specialist disposal that you didn't actually need.
That is the management challenge, boiled right down.
It's all about training, though.
It's a constant training requirement to make sure workers understand the flashpoint, the corrosive nature, or the toxicity of what they're handling, not just that it looks dirty.
Precision here saves money and protects people.
Exactly.
Okay, moving on to our final category. We're shifting from chemical hazards to just physical volume and mass.
Right.
And that's the black or gray bin, the heavy lifters.
These bins are dedicated to dry waste. You see them mainly with construction, demolition, heavy infrastructure projects. This waste is stable, but it is massive.
So we're talking about construction debris, concrete waste.
Bricks, tiles, large amounts of soil and rubble.
Yeah.
The key characteristic here is just the sheer weight and volume. Black and gray materials often need specialized logistics.
Heavy-duty skips, special transport permits.
Industrial loading equipment, like front-end loaders, just to handle them. The structure of the waste itself dictates its segregation. It's completely separate from the green-blue recycling stream or the red-yellow hazard stream.
All right, now that we've clearly established the what goes in each color, we need to spend some time on the how.
Yes.
Because a perfect color code system is useless if the site operations are unsafe. So let's look at the crucial operational controls and safety guidelines from our source materials.
We have several universal general safety rules that have to be followed on any site. These rules are really the foundation of compliance.
And the number one rule is?
The primary behavioral check is simple. Never mix different waste types. Any mixing immediately undoes all the segregation efforts.
And the standards mandate some basic but critical PPE.
Yes, workers have to wear gloves when they're handling waste disposal. It minimizes direct contact, which is especially important with those yellow and red materials.
Makes sense.
And then there's operational safety, managing the physical risks. All bin lids have to be kept closed.
Why is that so important?
To prevent ignition sources from reaching potentially flammable waste, especially in those red containers holding solvents. And workers are mandated to report a damaged or overflowing bin immediately.
Because a failure to report turns a small problem into a big, uncontained hazard.
Exactly. But the highest mandate, which connects right back to our red-yellow discussion, is training.
Mandatory training.
All workers must be thoroughly trained on the color code system.
Yeah.
You can't just assume they'll figure it out. The risks are just too high.
So now let's see how these general rules get tailored to the specific environment. Let's start with a factory site.
Okay, factories. They often deal with consistent chemical generation and a lot of workers in a confined space.
So the protocols for factories focus heavily on accessibility and managing that chemical risk.
Right. The standards require placing bins near workstations for easy access. It minimizes how far a worker has to carry potentially hazardous materials across the floor.
And what about frequency?
Given the volatile nature of materials in many factories, the source specifically says hazardous waste, the red bins, must be emptied more frequently than general waste.
That reduces the time those volatile chemicals are just sitting there on site.
Precisely. Furthermore, they have to ensure proper ventilation around those chemical waste bins to prevent fume buildup and exposure.
That's a huge one. And there's also a language component.
A very important one. Factories often have diverse workforces, so the standards emphasize that bins have to be labeled clearly in local languages.
Right, to make sure compliance isn't hampered by a communication barrier.
Now, if we switch gears to construction sites, the challenge shifts dramatically.
We're moving from a confined chemical risk to open air, heavy traffic, physical movement hazard.
Exactly. The primary safety concern on a construction site is interaction with heavy machinery.
So the rules would be about placement
The standards dictate that bins have to be positioned well away from heavy machinery zones.
to prevent collisions, tipping, getting in the way.
And since construction creates so much structural debris, they require larger capacity, black or gray bins, and those bins have to be secured.
Secured from what?
From the wind, mainly. Being outdoors, the standards say they have to be secured to prevent tipping, which would just spread waste everywhere and create a massive hazard.
And finally, because of that high volume, I assume they need a strict schedule.
Construction sites must schedule regular collection to prevent overflow. Overflow on a construction site quickly becomes a physical obstacle that can impede machinery and compromise everyone's safety.
These site-specific rules really show that compliance isn't just a checklist.
No, it's an active process of risk mitigation that's tailored to the operational reality of that industry.
The color code is the language.
And the site protocols are the grammar of safety.
So what does this all mean? We started with some basic definitions, and we ended with high-level operational liability. These universal color-coded waste management and safety standards are really a masterclass in organized risk control. It's not just about what you throw away.
No, it's about where you throw it and how you manage the liability that comes with it.
So understanding those major distinctions, green and blue for resource recovery, red and yellow for chemical risk, and black and gray for structural mass, is just essential knowledge for anyone in these high-stakes environments.
And if we connect this to the bigger picture, you see that the whole system is built on precision.
Right.
While technology and regulations define the rules, safety ultimately hinges on human adherence and constant training. The goal of this complex, multicolored system is actually simple:
Which is?
to eliminate ambiguity so that compliance becomes automatic.
But, as we noted, the system is designed to remove that ambiguity yet. We know the general rules include never mix different waste types.
Right.
While the yellow bins are defined as containing mixed materials like contaminated packaging and broken equipment.
It creates a fascinating gray area, a moment where the training collides with reality.
It does. So here's a thought for you, the listener, to mull over. At what precise point does a collection of varied items in that yellow bin, the general, mixed junk cross a threshold and become a legally dangerous contaminated material that must instantly be rerouted to the red bin?
That precise point of judgment, based on a worker's experience and their training, remains the single most critical human variable in this entire safety system.